Welcome back again, Science Warriors, for the next video here in our Flip Classroom series. Today we're going to be going through TEK 6.6a, Metals, Nonmetals, and Metalloids. Our EQ for today, or our essential question, is going to be how are physical properties of matter used to classify elements into the three main groups? So let's just jump into it. First of all, find page number 21 of your journal, and I want you to set up your Cornell notes. Remember, the title line holds your essential question. Then you need to draw a line probably about 3 fingers width from the center of your journal to create your question section and your note section, and leave about 4 or 5 lines at the bottom for your summary section. So to get started, what are the 3 main groups for elements? Well, we kind of mentioned them on last Friday: metals, nonmetals, and metalloids. Each of these groups are going to have very specific properties that identify them as being a part of that particular group. These properties do not change unless if there is a chemical reaction occurring. So today we're going to assume that there are no compounds being made and that they are going to stay in their pure element form. So we have an example of metals, nonmetals, and metalloids here. Well, what are these physical properties? Well, metals, nonmetals, and metalloids, or you can abbreviate as M, NM, ML, are classified by typically 5 physical properties. Now, before we talk about what those are, let's remember what a physical property is. It is something that we can measure. It's a characteristic we can observe, and it describes the physical state of something. It has nothing to do with how it reacts with other things or how it may change chemically. It has only to do with its physical characteristics. Well, the 5 properties that we look at are luster, conductivity, malleability, ductility, I can't even say the word, ductility, and then of course the state of matter in which it is at typical room temperature. So some examples of luster right down here, and this kind of shows us some of that luster, malleability, and we can also guess to its conductivity from here in just a moment. So let's start off with luster. Luster is the way that the surface of the mineral or of the substance reflects light. So if you shine a light onto it, what does it look like? How does it reflect that light? There are 5 examples of luster. We have metallic, silky, dull, glassy, and what is called resinous. So a metallic luster is going to look like this. It's going to reflect light very, very strongly, and it is going to be very bright under a light. Silky or dull can be more like this sample here. How it has a dull, it does not shine, light does not reflect off of it the same way that the metallic does. So we can consider this to be dull. In this middle picture, this would be an example of glassy. How it will reflect at certain angles, but then at others we can either see through it or we can see the actual color of the substance. And then the last one, resinous, is like the amber made from trees. Kind of translucent, almost kind of milky in color or see-throughness. Opaque is a word that you may be familiar with, but resinous is going to look like this. Next, we have conductivity. Well, conductivity is the ability for something to transfer heat or electricity. There are 3 designations for how a substance moves heat or electricity through it. One is that it's an insulator. It's not a very good material to transfer either one of those 2 things. We have conductors, which allow electricity to travel very easily through it. And then the last one is called a semiconductor. We'll talk a little bit more about what semiconductors are here in just a little bit. But these are the 3 ways that you can describe a substance's ability to be conductive. Next, we have malleability, and this is a fun one. You can always find great examples of this, and I will try to post a link to a video where we get to see malleability at its best. But malleability is the ability of something to be reshaped without breaking. So I want you to imagine that you're hitting it with a hammer, and when you do, does it bend or break? If it bends, like metal, we consider that to be malleable. Okay? It is able to be bent and not shatter. Whereas if it was brittle, once you hit it, it is going to break up into a whole bunch of different pieces. Next physical property is called ductility. Now, ductility is related to malleability in that it has to do with how something can change its shape and not break. Excuse me. So the ability to be drawn out into a wire, so to take a block of something or of any substance and start to pull on it and make it thinner and thinner and thinner, or to squish it down until it gets thinner and thinner and thinner until it forms a wire, that means that this substance is ductile. It can be drawn into a wire. Just remember that we start with one length or width of a substance, and we can then squeeze it down to make it even thinner. And as we make this draw plate have an opening here and here, thinner and thinner, then our wire will decrease in its diameter, so the wire itself will get thinner. Okay, so those are the properties that we want to worry about. Let's start talking about what it takes to be in each of the categories. So the first one is going to be metals. Metals are classified by having these typically 5 properties. There are a few exceptions. Just like any rule, there are exceptions to the rule. But first off, they are going to have a shiny or metallic-like luster. Makes sense, metallic metal. They are going to be malleable. They are going to be able to be bent and not broken. As we do know, some things can be broken, but they are going to resist that up to a certain point. So don't get confused that just because you can bend a paper clip a whole bunch of times and then break it, that is still, because you can bend it without it breaking the first few times, that is still considered to be malleable. Also, metals tend to be good conductors of electricity and also heat. This is why we use metal in our cooking ware. And usually they're going to be solid at room temperature. There is one exception to that one though, and that is the metal called mercury. And that is the picture we have right here. Mercury is a metal that is in the liquid state at room temperature. It is also a very poisonous substance to humans. So if we get this in our system, it can cause some major issues. And then of course, one more thing that's interesting about metals is that a few of them are magnetic. Now this is not a telltale sign that it is a metal, because not all metals have that trait, but it is definitely one that we can take note of. So now for the second one, the nonmetals. Nonmetals, of course, are things that we usually don't think of as being metal. These should be pretty easy to identify. So their main properties are, of course, that they have a non-metallic luster. So they're not shiny. They're going to be dull. They're going to be brittle if they are in the solid form. Of course, things like oxygen, which is a gas at room temperature, cannot be hit with a hammer and see if it bends or breaks. But if it is a solid, like the charcoal we see here in the picture, if I hit that with a hammer, it is going to fall apart and break into a whole lot of different pieces. Nonmetals as well are bad conductors of heat and electricity. This is why they are considered what we call insulators. They can protect people or things from heat and electricity. And then lastly, nonmetals can be found in any of all 3 states of matter at room temperature. We have examples of solids like carbon, liquids, as well as gases. So this one is not always a telltale sign of whether or not something is a metal, nonmetal, or metalloid, in that there are some that can be any state. Okay, and then our last group is going to be metalloids. Metalloids are classified as having a shiny or dull luster. They can be malleable or brittle. And many of them are considered what we call semiconductors. This means that they do not conduct electricity and heat as well as a metal, but they conduct it much better than a non-metal. So they're kind of like in the middle. So semi means half. So if up here is metal, down here is non-metal. Down here is an insulator, up here is a conductor. semiconductors are going to be right in the middle. And most of these metalloids are going to be solid at room temperature. So metalloids are tough to identify because they can have mixtures of the properties of the others. So the way that you tell is that you have to know the properties of a metal and a non-metal. If your substance has a combination of both metal and non-metal properties, then you are working with a metalloid, because it's kind of like a little bit of being both at the same time. These, of course, are the elements: boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Metalloids work really, really well in electronics, so like circuitry and circuit boards, where a lot of electricity all at once can cause these circuits to fry and burn up and no longer work properly. So these semiconductors make it possible to send electricity through these tiny, tiny, tiny little wires and through these tiny chips, and allow for it to not fall apart, or not to cause a problem that can cause the electronics to break and quit working. So now that we've talked about the three main groups and how to tell what properties lead us into what a substance can be, this is what I would like for you to do. We are not, I repeat, we are not doing the questions section or the summary section of our Cornell notes today. What I would like for you to do instead is on page 20 of your journal. So if you have your journal, this side is where your Cornell note should be on the left-hand side. I want you to title this page 5 items identification. You're going to pick 5 items from your home, and I want you to give it its name, tell us what the name of it is, describe its physical properties based on some of the ones we've talked about today, and then I want you to identify that item or part of that item as a metal, non-metal, or metalloid. So make sure that you have 5 different examples. So don't just pick a chair that has a wood back, metal legs, and do that as a metal and non-metal. Pick 5 different items. You can pick the whole item or a particular part of it and identify that. Well, anyway, Science Warriors, thank you for watching this video today. I look forward to seeing you. This video will be due Thursday when you come to class, so please make sure that you have this ready so that we can continue on with our activities, and you will be all caught up with the information that you need in order to continue on with class. Have a great night, and we'll see you guys next time. Peace.